Audio Jungle. Audio Jungle.
All right. Question is draw SFD SMD and BMD for the single side overhanging beam. Single side overhanging beam subjected to,
So are you writing something on the screen?
yes.
Because I can't see it as
Oh,
hanging for. I mean, the
right,
screen is
right.
hanging.
Okay. Wait. Subjected to loading as shown below. Okay. Here you just see what they are asking for that particular beam. First I will draw the beam here now. This is the beam. Okay, this is the beam now, and we have support. This is the support, and here also we have support. This is the single side overhanging, single side. So here it is overhanging 5 Newton. Then here it is 2 kilonewton. Make it Newton, okay? Kilonewton. 5 kilonewton, right? 5 kilonewton. And from here to here, it is UDL only. Right. And this value is nothing but 10 kilonewton per meter. And if you see, this point is C, this point is A, this point is B, and this point is D. So distance between A to C is 4 meter, right? This is 1 meter and 2 meter, right? In this problem, what they are asking determine the absolute, or determine the maximum bending moment and shear force. Okay. Also locate points of contraflexor if any. Okay, if any point of contraflexor is there, then also we need to calculate that. right? So solution of this problem, see, again we have to draw the beam. Simple, this beam is what, something like this, and see the supports, this is the support, and here this is the another support. This point was RA, check it, this point was RA and RB, this is RB, and here one more load is what acting, which is nothing but 2 kilonewton. See, it's a 2 kilonewton, and here also one more load is what acting, which is nothing but 5 kilonewton. This distance is nothing but 2 meter. Naming of this point is D, and this is what C, and this location is what, from here to here it is 1 meter. Okay, 1 meter, and now this distance is nothing but 4 meter. This point is nothing but C. All right. And if you see, we have UDL, it is spread from A to C, and the total distance is what, 4 meter now. So UDL, you know how to convert UDL into total load. So now what will be the total load? It's nothing but whatever the UDL load we have into length, up to what distance it is spread. So what is the UDL? Uniformly distributed load, it is 10 kilonewton. 10 kilonewton per meter into what is the length, up to what
4.
distance it. So this value will be meter cancel out, it's nothing but 40 kilonewton, right? So, and where it will be acting, last class I had explained UDL will be acting at the mid of span. So I can say
Yeah.
this is now 2 meter and this is now 2 meter, right? So it is acting at mid of the span, and now total load becomes 40 kilonewton, right? What is your first step? First step is what? To find the reaction force. Step 1. Finding reaction forces. What are the reaction forces? It's nothing but RA and RB. Okay, so we have equilibrium equation. What are the equilibrium equation? Equilibrium equation, we have to take moment about point A and make it equal to 0. We have to take moment about point A and make it equal to 0. So what will be the equation? See, this is the point A, this is the point A here, and once take moment, then 40 kilonewton will give the moment, 2 kilonewton will give the moment, RB, because of RB force, will give the will get the moment, 5 kilonewton will also give the moment about point A, but because of this RA will not have any moment. So we'll write this equation. So about point A, 40 kilonewton will give the clockwise moment, so plus 40 kilonewton into 2 meter. From point A, distance is 2 meter. Similarly, 2 kilonewton, total distance will be 2 plus 2, 4. So it's a 2 kilonewton into 4, right? Then we'll go for the RB, which is going upward direction. So this RB will give anti-clockwise moment, and total distance will be 4 plus 1, that is 5. So minus of RB into 5. Check, 5 kilonewton will also give the clockwise moment about A. So 5 kilonewton into perpendicular distance will be 4 plus 1, 5 plus 2, 7. So it's nothing but 5 into 7 equal to 0, right? This is the RB into wait, RB into 4 into 5. Next step I have to write. Sorry, we just correct this. RB into 5, and 5 kilonewton, which will give the clockwise moment, and total distance will be 7. So plus again 5 into 7, make it equal to 0. So we'll write this value. So you just check it how much it is. So it is nothing but
24.6 is coming. RB.
okay, minus 5 times RB plus 35 equal to 0. Okay, now tell me dear, what is RB? RB is
24.6.
right, kilonewton. And similarly, we have to calculate another equilibrium equation, which is summation of all forces in upward direction will be 0. So downward force will be negative and upward force will be positive. So what are the upward force? It is RA plus RB. Is all this RA plus RB is equal to downward force. What are the downward force? Check 42 and 5. So it's nothing but 47, right? Nothing but 47. So how much RA is? 47 minus 24.6. How much it is?
22.4.
Right. So these are the reaction forces. Once reaction forces are done, now easily we can move for the shear force diagram. So now shear force. Calculation of shear force. How to calculate? Again, we have to draw the actual beam. So now this is the actual beam. You have to focus here. This, all the UDL and all forces actual beam we have to draw. So this is nothing but RA. Just now you got the value. It's nothing but 22.4 kilonewton, and RB just now you got it's 24.6. This is nothing but 5 kilonewton. This is nothing but 2 kilonewton. This is 2 kilonewton, and here this is nothing but after 2 kilonewton we have a UDL. This is UDL force. And the intensity of UDL force is nothing but 2 kilonewton per meter. What is this distance? If you check, it's nothing but 4 meter. This distance is nothing but 1 meter. This distance is nothing but 2 meters. What is the first step once you are going for calculation of shear force? You have to mark the points. How to mark these points? You just make it. You just make it dot lines. You'll see here, so you will understand. See, because this is the RA force. So just before this RA force, you just mark, and this is 0, 0. After RA force also you have to mark, this is 1, 1. Okay, right. Similarly here, this is the force now, so you mark it. It's nothing but 2, 2, and this is nothing but 3, 3. Similarly here also we have force, so this is 4, 4, and this is nothing but 5, 5. And here this is nothing but 6, 6. You can take it 7, 7. All right. Very good. Now calculation we have to start. So if you see the calculation, so what is the F00? Obviously before reaction force nothing is there, so this will be 0. But if you write F11, if you write F11, then this value is nothing but, see, if you reach 11 means at this point if you reach, then RA will come first, then 11 point you reach. Means you cross the RA, it means RA will be considered now. Because you are moving in this direction. Okay, you are moving in this direction. So if you are at 0, 0, so obviously there is no beam, nothing is there. So that's the reason this value is 0. But if you reach at point 1, 1, cross section 1, 1, then meanwhile you will be able to reach to point RA, to force RA also. So RA will be considered. So what is the RA value? It's nothing but 22.44. 22.4 kilonewton, and it is in upward directions, hence it is positive. Similarly, if you go for the F22, now if you check upward force RA, you have taken 22.44 kilonewton, but see this UDL direction is all here direction, if you check, it is a downward, means it's a negative force. All upward forces will be considered as a positive, all downward forces will be considered as negative. Now what is this UDL value for the span? Because you are now reached to point 2, okay, means it is almost point C. This is C and this is what? B. This is what? A, and this is what? B. So just before C, so it started from RA and till C, that UDL value is what? 10 kilonewton per meter, and 10 kilo into 4. That will be the total UDL value, that is 10 into 4, which is nothing but 40, right? So, or I'll make a product only, so you will able to remember how it comes. 10 into 4. So what is this value? 22.4 minus 10 into 4. It is minus value, minus 17.6 kilonewton, right? Similarly, we can get F33 also here. Similarly, we have to calculate F33. So once you reach to F33, then meanwhile you will able to cross this 2 kilonewton load, because you are going for 33. So till F22 it is nothing but minus 17.6. But if you reach to point cross section 33, then in between 2 kilonewton force comes and it is acting in downward direction. So downward direction value will be negative, becomes minus 2. How much? Minus 19.6 kilonewton, right? We'll go to then F44. If you check F4, it is just before the RB, and 33 and 44 both value will be same, because in between we do not have any force, so it is 19.6. It is similar one, same value only, right? Now coming to the F55, if you check F55, so till F44 it was 19.6 minus value, but if you reach F55 cross section, then RB load will be considered. RB is the reaction force and it will be considered, and it is acting upward. So upward value will be considered as positive. So before, till 44 it was 19.66 minus value. Now once you go for the F55, so RB will be considered and it is in upward direction, hence it will be positive, 24.6. If you check F55, so this value is nothing but a minus 19.6 plus
Guys,
24. It's a 5, right? And then we'll go to the F66. So see, in between 5 and 6 we do not have any force, so same value you will get, it's 5 kilonewton. Now reach to F77. So once you till 6 it was 5 kilonewton, and once you jump to the 77, so between one force we have, that is 5 kilonewton, and this 5 kilonewton is acting downward, so it will be negative. It will be negative, so it becomes 0. See, this value and this value must be same. Why it is same, I already explained. Because 0 value is what? Just before beam is starting, that is 0. So obviously just before beam is starting it will be 0. And F77, that value will be just after ending the beam. So after ending the beam also force should be 0. So that's the reason you are getting 0. This is the cross check, always remember this, okay? So once you got shear force, so now we have to draw it. So as I told you, once you are going to draw beam SFD, then again you have to draw beam exactly, and then you extend the all forces points downward, and then nicely you have to draw. So there will not be any mistake. Otherwise, chances are there you may commit mistake. So better first again we'll draw the beam. Now this is the beam here, see, and obviously this is the force. This force is nothing but 5 kilonewton. This force is nothing but 2 kilonewton, and obviously we have a UDL load here like this. Check the intensity of this load, 10 kilonewton per meter. How much it is? It's a 4 meter. Dimension not required, but if you want you can write. And this is nothing but 1 meter. This is nothing but 2 meter. This is D, this is B, this is C, and this is what? A. Okay. We have to extend this, all points where the forces are acting, we have to extend this downward. Okay, like this, something like this. Right. We should aware with this forces also. Here we have a RA, and this value we know it is nothing but 22.4 kilonewton. This is what RB, and it is nothing but 24 point. Rest all forces aware, you are aware, 2 kilonewton, 5 kilonewton, right? Now to draw the SFD, first you draw the reference line. Now this is our reference line. If we are saying reference line, so you can make it 0 0. From 0 0, if you go upward it will be positive values, and if you go downward it will be negative values, right? Now let us start. So we can have, see, between A to C, what loads we have? We have a UDL load. huh? So I already have shown the pattern in the table in starting only. If we have UDL load, so for Shear's diagram we have to draw incline, we have to draw the pattern for UDL load in SFD shear force diagram, that is inclined line, that is inclined line. But before that, at point A we have to check the force. At point A, what is the force? 22.4, which is plus, so we have to go plus first upward. Now here we reach, this is nothing but 22.4, right? This is at point A. And at point C we have to check what is the force at point C. At point C means 2 2 and 3 3, we have to check, we have to check 2 2 and 3 3. So see this, obviously 2 2 and 3 3 both values are differing, minus 17.6 and minus 19.6. Okay, so it's very clear, like this 17.6 is just before the point C, and F33 is just after point C. Means that 2 kilonewton, once it is considered, then it becomes minus 19.6. Before considering 2 kilonewton, it is minus 17.6. So if you think, because of the UDL load, what is the value you are getting at point CC? It is minus 17.6 without considering 2 kilonewton. So first we need to show this 17.6. Where will show? Obviously it will be at point C. So I can say this value is nothing but, this value is nothing but 17.6. Okay, this is the 17.6. Just now see this value, 17.6 kilonewton, and this is 22.4, and this is 17.6, and we have to meet this, we have to meet with inclined line, right? This is the RA and UDL load. Now if you consider this 2 kilonewton also, so once you consider 2 kilonewton, means you will be reached 0.33, and what is the 33? 19.6, and it is still negative. So 17.6 we have, and if you want to connect, I mean if you want to write the 19.6 value, which is exactly for point C, so it will be downward. This is now 19.6. This value is nothing but 19.6. Always remember, just before C value is 2 2, just after C value is 3 3. So around the point C value is what differing. Why? Because at point C 2 kilonewton is what acting, but 2 2 and 3 3, which is related to point C only. For that reason, at point C, if you see the variation, these two loads you are getting 17.6 and 19.6, which is related to point C only. You should understand this 17.6 will be just before C, and this 19.6 just after C. So if it is just before or just after, then on the same line you have to show. Okay, it doesn't matter it is force or moment, but if you are writing for just like here, see, you can ask like for point A, just before and after. What is just before? Just before is 0. What is the value after A? So after A is nothing but 1 1. So this is the just before and this is the just after. So if I want to show both just before and just after, then what I will do? Just before value is here, it is 0. See, this value is nothing but 0. And just after is 22 points. So both I am showing. And if you are showing any number just before and after for any point, so both numbers should be on the same line. Like for point A, just before is 0 and just after is 22.4. So on the same line only I am showing these two data. Similarly, for point C also, just before and just after value you have to write. So just before is nothing but 17.6. Just before is nothing but 17.6, which is 2 2, and just after means 3 3. For C, 3 3 is nothing but just after C, which is 19.6. So both value I have to show on the same point, on the same line. Right, now coming to B. So for B, if you check, next is nothing but F44. So because F33 and F44 in between there is no force, so it will be same value, which is nothing but 19.6. So you have to draw one line which is nothing but same value, that is 19.6. This is just before B. Just before B in the sense, just before B is a 4 4. Now just after B nothing but 5 5. So if you go for 5 5 becomes 5 kilonewton. So on the same line we have to show 5 5. On the same line we have to show the 5 kilonewton. So 5 kilonewton is what? Positive value. So I have to on the same line only, but I have to go in upward direction because I have to show the 5 kilonewton value. So somewhere here this is nothing but 5 kilonewton, right? On the same line. This is just before of B and just after of B. Now coming to the D value. So just before D means 6 6. So F5 and 5 5 and F6 6 will be same because there is no force here. So this value will be same. So I can draw 5 kilonewton same means here, like this. And check the, see, if in between there is no force, so we have to draw horizontal line. If there is the UDL, then we have to draw inclined line. See here, we do not have any force, we can draw horizontal line. So you need to understand this also. Just after D, what is just after D? It should be just after D. Just after D means 7 7, it should be 0. So again we have to reach to the 0 point. So we have started from 0 and again we reach to 0. So this is the SFD. Now if you want to show it clearly, then you can draw the hash line like this. Okay, this is the hash line, so it will be more clear now. Okay, this is the SFD, shear force diagram. Obviously upward direction, upward to the reference, whatever the value, it will be positive. This value will be positive, and downside it will be negative, right? This you need to remember this now. So this is what the SFD for this particular case. Now we are moving ahead for the bending moment diagram. So for the bending moment diagram, what we have to calculate? We have to calculate moment at each and every points, right? So now moving ahead, for moment calculation, we have to write, we have to draw the diagram. So moment calculation. Moment calculation. So again, we have to draw the beam. So check here for this particular beam. This is nothing but RA. 5 kilonewton. This is what RB. RB, you know, it's nothing but 24.6. kilonewton. This is what 2 kilonewton downward, and we have UDL here. It's nothing but 10 kilonewton per meter. 4 meter. Right. All the dimension and all you have written here. Correct. Now we are going to calculate the moment. So at the end of the beam, always, last class also I had explained, this is RA, this is RB, this is C, and this is what D. End of beam, always moment will be 0. Last class I have proved and I have shown you also. So this is the point A and this is the D. So it is very clear, even if you want calculate also, end points moment must be 0. Okay, so directly you can write, doesn't matter it's simply supported or overhanging beam, end points moment will be 0. All right, now what is the next point? We have MC. So what is the moment at point C? What is the moment at point C? So it will be the moment because of RA. What was the RA? If you see here, it was 22.4. It was 22.4. If you want to calculate moment at point C, so because of RA will give clockwise moment for the point C. So about C, RA will give the clockwise moment. So it is plus 22.4 into perpendicular distance 4 meter. And this UDL which is acting downward, so it will give anti-clockwise moment about point C. So what are the what are the forces here? It's nothing but UDL 10 into 4. Where it will be acting? It will be acting at the mid of the span. So mid of the span means this is 2 meter and this is 2 meter. What is the total UDL? It's concentrated load now, it is 40 kilonewton. So 40 kilonewton into perpendicular distance 2. Okay. So this value will be what? This is nothing but 22.4 into 4 minus 10 into 4 into 2. So nearby 9.6 kilonewton meter. 9.6 kilonewton meter will be there, right? 9.6 kilonewton. All right, so MC means moment at point C, you got 9.6 kilonewton meter. Similarly, we have to write moment at point B. If you write moment at point B, then it will be what? Again, because of the RA force 22.4. Now, what is the perpendicular distance? 4 plus 1, because we are taking about point B. This is the point B. So 4 plus 1, that is the 5 meter. And again, this UDL uh, force will give the moment about point B. So total UDL you have converted into concentrated load. So it becomes 10 into 4, 40 kilonewton. Now at mid it will act. So 2 meter from C it will be acting. But now you are taking moment about point B. So 2 plus 1, this one also, because now this distance you have to measure. So this is what? 3 meter. So this is nothing but 3, right? And 2 kilonewton, if you check, it is also here. We have it is acting downward. So minus 2 into what is the perpendicular distance now? This 1 meter. So 1. Okay. Is equal to, if you calculate this value, so it's nothing but 22.4 into 5 minus 10 into 4 into 3 minus 2. It's coming minus 10 kilonewton. This is the moment, right? And as I have already given, at end of the beam, which is nothing but MD, it will be 0. Okay, it will be 0. All right. So, and once you got the moment, then we have to draw the moment diagram. Okay. So for the moment diagram, again, as I told you, anything, if you are going to draw SFD or BMD, so always first you draw the beam, and below the beam all the forces or moments what you have calculated you just extend there. So then only it will be perfect. Otherwise chance of mistake will be there. Okay, 5 kilonewton. This is D, this is nothing but B, which is RB, and you have calculated 24.6 kilonewton, and moment about B you got just now, you got here, it's nothing but MB, it's minus 10 kilonewton. So minus 10 kilonewton, and here MD you got 0, and then one more point which is nothing but C. You just say 2 kilonewton, this is point C, and at point C if you check what is the moment you have calculated at point C, it's nothing but 9.6 kilonewton. So moment about point C, it's nothing but 9.6 kilonewton, and obviously this is the UDL here, 10 kilonewton per meter, and about RA obviously you have calculated moment about point A, this is the RA only. If you want to write value, 22.4 kilonewton, and if you check MA, that is moment about A, is nothing but 0. So now all the points you have to extend downward, and already you have calculated moment about each and every points. Now this problem is what? Easy for you to draw the bending moment diagram. Okay, we'll have to take one reference line, as I told you, that will be 0 0 horizontal line. If anything you are getting positive, then it will be upward, negative it will be downward. You just say this is 0 0 reference, right? Now coming to A to C, check this is what UDL, and everywhere you have calculated like moment at point A you have 0, so we'll start from 0. What is the moment at C? It is 9.6. So what is the mean of 9.6? That is the positive value. 9.6 is what? Positive value, right? 9.6 is nothing but positive value here. So this is the positive value, 9.6. Okay, 9.6 I can write here. This is 9.6 kilonewton meter. All right, and at B, that is moment which is nothing but negative. So you can say this is nothing but negative. How much it is? 10 kilonewton. So I can say this is nothing but 10 kilonewton meter, negative value. And again D becomes 0. So here this value is nothing but 0. Here also we have 0. This point is done. In the problem itself, they had asked one thing. If you concentrate, this is very special problem actually. What they had asked, if you read the problem once, then they said uh, where is the maximum bending moment, or where is the maximum moment value? I think they had asked. Let us see what they said. Determine the maximum bending moment. See, this is lines. Okay, so maximum bending moment, where will get the maximum bending moment? So this point you make the note of it. Always remember, the maximum bending moment you will get where shear force is what? 0. Where the shear force is 0, the maximum bending moment will occur there. Okay, so always remember here. Let me write this first calculation. We need to, because we are drawing the bending moment, so if we know the where is the maximum bending moment, so it will be better for us. So before drawing bending moment, just find the calculation of maximum bending moment. Calculation of maximum bending moment. So for this, you two lines theory is important. You make a note of it. It's nothing but maximum bending moment occur at the section where where the shear force is 0, where the shear force is 0. Now, so where shear force will be 0, how you would know? How you would know where shear force is 0? For that, we have to go shear force diagram. Now check where is the shear force diagram. We'll try to find out this shear force diagram and see this. This is the SFD shear force diagram, and in this shear force diagram, where the shear force is what? 0. At this point, shear force is what? 0. Check it. So at this point, shear force is 0. Hence, we need to first find the location. Generally, after saying this, we can mark this. Okay, this is the point where shear force is what? 0. I can consider these points because this is nothing but A. This is nothing but B. This is what? C, and this is what? D. And I can mark this is what? E. So at point E, shear force is what? 0. Right? Now, what is this location? If you want to get this location, so how to get it? It's a simple. So at this point, we need to write the shear force equation. So at point E, what will be the shear force equation? Check. At point E, what is the shear force equation? So at point E, just like you have calculated, see, F11, you have calculated 22.4. Then directly you jump to F22, which is nothing but 22.4 minus 10 into 4. Why you have taken 4? Because you have taken full span length. You have taken full span length, but your shear force is what? Going to be 0 in this distance only. So can I take this distance is nothing but x now? This distance is nothing but x now. Now if I say what is the shear force Fe, so we can say just like here, what we have written, just concentrate so you will get it. This point, this F22, you have calculated 22.4. Why 22.4? Because this RA is what? In upward direction. Then UDL is acting downwards. 10 into full span length you have taken. Now instead of full span length, this 4, now you have to take x distance. Okay, so the same equation will be there, but now it will be 10 into x, because I'm taking x distance, I'm not taking full span length. If you take full span length, you will reach at point C, but where your shear force becomes 0, it is in between, it is just before C. So better you take this, consider okay, this distance is now x. You take one section, you just say this distance is nothing but x, maybe here or anywhere you can. So this is the xx section, and from starting xx section distance is nothing but x. So now if I calculate what is the shear force, that Fee, or you can write Fxx section, what is the shear force now? So it is nothing but 22.4 minus the same equation you have to write, like just now you have written here. See, the same equation you have to follow. 22.4 minus 10 into 4. So instead of 4, you have to write x. So it will be 10 into x. Okay, is equal to shear force becoming 0 at xx section. So this is 0. Now what you got? 22.4 is equal to 10x. 10x. So what is the x distance? It is nothing but 22.4, means 2.24 meter. So now it is calculated like your shear force is what? Becoming 0 at 2.24 meter. At 2.24 meter from end A, right? So this is the point where shear force is what? Becoming 0. So now it's very clear, at distance 2.24, I can consider 2.24. Now this is what? 2.24. Just I head to the mid section, because the whole length is what? 4. The whole length is what? 4. Okay, the whole length is what? 4. Just listen carefully. So this will be 2 meter, and this will be 2 meter, because the whole length is what? 4. So 2.24 will exist somewhere here. This is your 2.24. Okay, this is your 2 point. So now at this point, your shear force is what? Going to be 0. This point you have taken E. Okay, this is what? A, this is what? B, this is what? C, this is what? D, and this point E is now your point where shear force is 0, and you got the theory where shear force is what, 0, your bending moment will be maximum. So where shear force is 0, x is equal to 2.24 meter from end A. Shear force is what? Shear force is 0. Shear force is 0. Now, so we'll calculate the bending moment at this point, because at this point moment is what, maximum. So that you need to calculate, right? That you need to calculate. So what is the bending moment at E? The bending moment at EE, or you can say at XX section, and this bending moment will be going to be maximum, no? Because here at point E, the shear force is what, 0. So at point E, you now calculate the moment. So what is the moment at point E? It's nothing but simple, very simple. That moment because of the RA force. So RA, you can write RA into, what is the distance of RA? Distance will be from this end, it is 2.24, exactly 2.24, 2.24, then minus UDL load. UDL load will be acting half of the span generally, okay? But now you are interested in UDL for till this distance, you have to discuss the UDL till this distance. This will be your UDL, where it will give moment about E. Further UDL will not be used. Now for this UDL, if you want to write moment, then what will be the moment? So for this UDL, the total force, what will be the total force? Intensity is 10 into this total distance is nothing but 2.24. 2.24, hence it will be 10 into 2.4 will be the force, and where it will be acting, it will be acting at the half of 2.24, right? Half of 2.24. So I will show you, it will be very clear. So RA 2.24 minus that moment will be force, 10 kilonewton is force, and it is acting to the span of 2.24. Just now here I have shown you, because this 2.24 is what useful for you. Rest it is not useful, because you are calculating moment. So always you take the left side of the beam. I told you right side forces you will not consider. So till point E only we have to take moment left side only, all the forces will take. So left side UDL is 2.24, reaction force is RA, this two force we have. So RA into 2.24 will be the reaction force moment, minus UDL 10 into 2.24, and where it is acting at the mid of 2.24, means 2.24 by 2. This is the distance where it is acting. All right. Right. So this value you have to calculate how much it will be. RA is nothing but 22.4 into 2.24 minus this value is 10 into 2.24 square divided by 2. So if you calculate this value, so it's nearby 22.4. Wait, 22.4 into 2.24 minus 10 into 2.24 square divided by 2. It's nearby 25.1 kilonewton meter. So now it's very clear, this value 25.1 kilonewton you got, this is the maximum moment. Now, so I have to show maximum moment, so this part we can remove. This was for just understanding only. Now we have to draw the bending moment diagram. So you got at point E maximum moment you will get, and that is nothing but how much? How much it is? It is nothing but 25.1 kilonewton meter. At point E, you will have moment 25 kilonewton at point E. So 25 kilonewton maybe exist here, 25.1 kilonewton meter. Now we are going to draw the SFD diagram. So how it will be? It will be like because UDL we have. So I have told you, if you are going to draw for the UDL, if you are going to draw SFD, then it will be inclined line. in table I had given, but if you are going to draw BMD, bending moment diagrams, it will be parabola. So this will be parabola. So parabola something like this. This is the parabola, and obviously this side also we have UDL. So this is also parabola, something like this. Okay. Now we do not have UDL. This is only forces. So this will be inclined line, right? 9.6 and 10 kilonewton meter. So this we have to meet here. This we have to meet here. It's nothing but this is the inclined line, because we do not have any this UDL or something, so it will not be parabola. Only parabola will be till from A to C. Okay, because A to C we have UDL. This is the inclined line because we do not have any force. And similarly between B to D also we do not have force. So after 10, this 10.4, because all the moments we have calculated, like if you go back and check here, if you go back, this moment we have calculated 10 kilonewton, then MD was 0. So this 10 kilonewton and 0 we have to meet with inclined line. Okay, so this is now the bending moment diagram. See, this is the bending moment. All right, then